we can have is, if I want the total charge to be 0, so I'll erase that and just put it dot 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 dot. That means that this charge has to be the same as this charge. But it could be either 0 or 1. So either both of these merge to 0, and both of these also merge to 0, or both of these merge, and both of these also merge to 1. So that's a qubit. So with 4 of these quasi-particles, I have 1 degree of freedom. I have 2 possible states. And that's often what people do, is they just, so you imagine that you have either this, so we're gonna have quantum states that look like that. Alpha that is beta times that, and so we're physically, this is really what we're gonna do. We're gonna have four of these impurities, or 4 of these localized excitations, whatever you want to call them, these quasi-particles on the plane, and that'll give us 1 qubit. And if we want a second qubit, we just have another 4, and another 4, and another 4. And so we're sort of embedding qubits into this topological system. It's kind of wasteful because we're only using some of them. There's many more dimensions that we're not using, but it's easy. So yeah.
So is it like an upside down tree?
Yeah. Or why is it upside down? It's right side up.
Oh, sorry. Oh. So looks like the,
Yeah, it's a tree. Yeah, the vertices all have degree 3. Yeah.
If we ended with 1 instead of 0, could we get more degrees of freedom?
It's hard because if you have a 1, that charge has to go somewhere. I mean, it has to link up to something. So if you don't have control of it, that means that 1 is going off into the environment somewhere. And you have to be careful about then what that's doing. So that's why we usually imagine that everything is merged to 0. One thing I guess, yeah, that's easiest. One thing I guess you could say is, let's see. You could draw it like this. So now I have 5 particles, where this one is a 1, but I don't have control. So I know that this is there, but I can't move it or anything. So it's part of the environment. And so these 4 merge to go to 1. You can imagine looking at this by themselves. Usually if they merge to 0, it's easier. So why is it easier? So it's easier because, right, so first of all, let me say, right, so we have these different pictures. With 4 particles, we have these different pictures, depending on in what order we zoom them in. And what these are, when you count the number of valid states